We're going to graph using calculus methods this function right here. So this one does simplify down. So when you factor out, these two cancel out, and so you get that the function is actually equal to 1 over x minus 3 as long as x is not equal to 3. So f of x is undefined at x equal 3. The x-intercepts, when you look at the numerator, which would have to be 0 for y to be 0, it's not 0. 1 is not equal to 0, so there's no x-intercepts, never crosses the x-axis. At the y-intercept, when x is 0, y plugs in and you get negative 1/3. Horizontal asymptote, as s goes to plus and minus infinity, you can see that in the denominator it gets very large, positive or negative. So y is going to 0. So horizontal asymptote is 0. Vertical asymptote at x equals 3. Now in pre-calculus we would have stopped right there and tried to graph the function. But we're going to continue on with our calculus analysis. So we take the derivative of y, we write it the correct way, and we get y prime is equal to negative 1 over x minus 3 squared. And we immediately notice that if we're going to look for critical points or level points where the y prime is 0, it's never going to be 0 because that negative 1 in the numerator is not going to be 0. So y prime is never 0, so there's no level points. Then we continue on with the analysis of the second derivative. Compute the second derivative, end up with 2 divided by x minus 3 to the third. So where is it concave down? Where is f of x concave down? When y double prime is negative. And if you're to the left of 3, the negative number cubed will be negative, so you'll be negative on negative infinity to 3, and you'll be positive after 3, except at 0, at 4, of course, the entire function is undefined, so is y double prime. So negative infinity to 3, the function is concave down. After 3, except at 4, function is concave up. Okay, so now let's graph it. So you have just rewriting the attributes that we had. I wanted to get another point after 4, so I just made up x equals 5. I evaluated that into the function, and it's 5 1/2. And then we have our y-intercept. So we start writing down what we have. Y-intercept at 0, negative 3. That's right here. We have a horizontal asymptote at y equals 0 along here. Vertical asymptote at x equals 3. We have a point over here at 5 1/2, somewhere in there. And then we look on the sign chart for y prime and y double prime, the positive negative sign chart. So we're looking at this. Y prime is negative, so it's decreasing. The function is decreasing before 3, and we have this solid point here at 0, negative 1/3. So it's decreasing, going down. But how's it going down? It's negative second derivative, so it's concave down, and it's approaching the asymptote at 3, so it has to do something like this. and it has to approach the y equals 0 line. So it's coming down here like this, concave down, decreasing. Then at 3 it has the vertical asymptote. That's here and here. In between 3 and 4, the function is decreasing. Okay, decreasing and concave up. We don't have any points in there, so maybe we should evaluate a point just to see where we are. So we choose x equals 7/2, right in between there, 7/2, and y turns out to be, when you plug it into the function, 2. So there you have your point, 7/2, 2. So we can graph up here to 2. Now we know where our point is. Now we see that the function is decreasing. There's an asymptote at 3, and it's concave up because of y double prime being positive. So it's going to decrease, but concave up. It's going to have to go through that 5 point. And here. Now after 4, and we have a little open circle here. So let me draw that again. We have an open circle at 4 where there is a hole there. So it goes through here, then it goes through here, and then after 4 it's still decreasing, and alright, so it's decreasing and concave up. So it continues to be concave up all the way there. And so out of the TI, this is what the graph looks like, and that matches up with what we have, except for it doesn't show the nice little 0 here. Not 0, the open circle.